right, this is the Jaenisch lab protocol for how to run the plate washer, because I'm not going to be here, and the machine still will be, and maybe in the future somebody wants to use it and is interested in how to maintain this thing. So, okay, so we inherited this from Susan Linsquitz's group, and we use it for ELISAs, and I'm going to show you exactly. So the setup is like this. If it needs to be moved for any reason, all of the tubes are fairly obvious and they're color coded in the back. This thing is the automated extra piece of equipment if you had like a big stack of plates that you needed to wash, but for the demo that we're going to do today, it's not going to be on because we don't need it. We only have one plate.
Two. No, one.
No, we have one plate to wash, right, with different stuff in it. And I'm going to go over how to turn on the machine and how to start it up and how to clean out some of the pieces that we're going to use, and how to program the washes appropriately for the particular use that we're going to do today, which is an ELISA for amyloid beta. Okay, so the first thing that we're going to do is turn on the machine, which is... button I think is behind here. Yep. Okay, great. So there we go. And if we were going to use the automated plate stacker, we would need to turn that on too, but we don't need to. Oh, what's going on? Oh, I see. It's because we do need to turn on the automated plate washer. It gets out of the way. There we go. This is a very real demo because it's not like working perfectly. Okay, so start it up again. Here we go. Try again. Good now. Oh, did we get rid of the... Turn on the vacuum. Okay. Perfecto. Cool. Alright, so the way that this is going to do is that these bits right here can be used for, so this part of the machine can be used for adding things that are in these three canisters. Right now there's water and PBS and I think some tris solution that the Lindquist lab used, but we're not going to use any of that today because we're just going to use it to suck it up. If you're using it for sort of a small throughput application, it's easier to use this particular additional device, and then you can just put your wash of interest into through this like tubing, and you don't need like 50 gallons to be able to do your small experiment. If you have a higher throughput application, these things are probably more effective to use. And they're all labeled as either A, B, or C, along with the waste container right here. And when we go to do the programming, I'll show you exactly what that means, if in the future that seems like it's useful. So okay, so all right, so search and remembering how to put together this this tube system, we're going to show you how to put this thing together because it's a little non-intuitive, or at least it is for me. So okay, so you have this this tubing system, which you can go ahead and get replacement tubes if necessary in the future from Biotek. But so the way that this goes is that you have your dispense tips, and you put it into this holster right here, and then the apparatus, oh no, I put it in the wrong direction, so there we go. So it should be with the flange facing out. Okay, there we go, with the flange facing out, and then this apparatus right here, and it sticks. And then this third cartridge, you kind of have to bend and put into the holding cassette on here, and then you press down, close this, and now you're ready to go.
Okay.
Okay, so now we're set up and we're ready, and yeah. And that is how you put together this part of the apparatus. The first thing that you should do is run a little bit of water through the tubing.
So this is the water?
Yeah, this is water. So if we go to the main menu, when you turn this on, there's run, quick, define, and utilities. This you don't really need. You can do this you can run the machine without using a computer, but that's a little more complicated than necessary. But quick is very useful insofar that you can go ahead and use the prime and the purge function. So prime we're going to go ahead and do right now, and we have the vacuum on, so we'll just press it, and from this you can go ahead and see that we're just getting liquid through the tube and washing it out. And we'll go over at the end of the video exactly what to do to clean out the tubes and make sure that you get the most use out of them. So okay, we're ready. And then if you press the main menu, it turns off the vacuum. Okay.
Where do you press it?
So main menu.
Okay.
Yeah. So once you press, so let's do it again. So we go to quick, we go to prime, press it.
And you keep holding it.
Yep, you hold it.
And you're kind of washing the tube.
Yeah, it's just you also don't want, at the beginning you're going to prime to be able to get all the liquid in so that it definitely adds the correct amount. Okay, and so once you're done, you press main menu, and the vacuum, the vacuum turns off so it doesn't make that noise. Okay, great. So so we've washed this out, right? And so the first thing that we're going to do is set up. So we've already washed. So before, when we turn this all off, we'll do a wash step for the tips. So we're fairly confident that everything's okay. If you wanted to be more anal, you could do a wash step, but we know that we're the only person that uses this machine, so we're okay. So we're gonna go ahead and get the wash buffer here, and
So
if you're being
40, and this is 40 also?
This is from a different kit.
Oh, okay.
So whatever your wash buffer is, if you're gonna do a small throughput wash, this is probably the easiest way to do it instead of making 50 gallons and putting it into one of these carboys down here. So this is wash buffer. You can go ahead and, so we can go to quick, and we can go ahead.
We need the two washes for two different things.
We do indeed, yeah. So we're gonna get there.
So I know that the first one is the 42, and then we'll go 40.
Yeah, we're gonna make this video really complicated.
Okay.
Yeah, so I'm just gonna go over how to how to use the machine here, and then we'll figure out the actual experiment offline. So I'm gonna go ahead and purge, right? And so we're just removing the liquid, removing the excess water from the tubing, which just means that it presses out on both.
And what did you press there?
Purge.
Okay.
Yeah, and then we're gonna go ahead and press prime again to be able to make sure that we get all of the liquid in. Okay, so we're basically ready. We're ready to do our washes, right? And so now I'm gonna go over how to set up our wash using the software. Okay, great. So I'm going to show you how to program the plate washer here to be able to do what you want. So the liquid handling control is where you want to click. You're gonna click there, and then this will pop up. And it's not any more complicated than just creating a little program to tell exactly what the machine should do. And I'm just going to open up our test program to be able to do this ELISA to show exactly what I mean. So here's mine.
It says RVP.
RNP wash test LHC should be the first one up there. So the first thing that we're going to do, so currently for our purpose of our experiment, we've let the ELISA material incubate overnight, and we want to remove it and then wash 5 times with 100 microliters of the wash buffer, right? So the first thing that needs to happen is an aspiration step. So so W in this instance indicates things that this particular apparatus is going to do. Right, so this can add and wash and do a variety of other things, where P on this indicates things that are going to happen with the capillary tubes. So So that's just how this works out. So we want this to do the aspiration. So we're going to go to W aspirate, right? And I have this. So each one of these steps, if you right click and go to modification, you can mess with a variety of other options here. So I don't know what vacuum filtration, but I put the travel rate to low because we want to try to be careful. We're not too sensitive to time here. So for our previous protocol, we've set it to loop 4 times, and we can set it to loop 5 times for 5 washes instead of 4 washes.
Loop 4 times meaning 4 washes, so we're gonna make 5.
Yeah.
That's what the protocol says. In this case.
Yep. Exactly.
It's 300 microliter. Yes.
Yeah, and that's fine. You can wash with how much ever volume you want. I don't know what so 300 microliters fills this totally fine. And so anything between the loop and the loop end is going to be looped that many times. And so you can go ahead and for the P dispense, meaning the dispense that's going to come out of the capillary tubes, right? You put in the volume, you put in the flow rate, and we can also. You can put in which parts of,
okay, got it.
Yeah, so currently this is all set to be able to work for a 96 well plate here. There is actually an apparatus to do a 384. It exists along with the kit here, along with the materials that are over there. This material, so you can also mess with the Z, X, and Y axis. In general, we want to put it right in the center of the well. That's what 00 means. And this is an appropriate Z height for the kind of micro wells that we're using. Right now, we have it set to only do, these number of columns. I'm going to set it to do 6 because that's for our particular experiment. That's what we're going to do. Actually, here, let's see. Where's our plate? So our plate here is half 42 and half 40, so we're going to go ahead and set it to wash for 40 for the last 6 columns, right? And then we're going to take these out when we do our wash.
Okay, so you already got it wash 40. That's why you're gonna do those, yeah?
Yeah, we're gonna wash for 40, right? I think that makes sense. So 1, 2, 3, 4, 5, 6. So now it's only gonna wash the 6 columns, and each of these. So for these kind of micro experiments, we can take out the those particular columns and be able to do it to change for different washes. Yeah. So okay, so we're ready to go.
Why don't you do entire 8 wells of that?
It automatically does that.
Oh, okay.
Yeah.
Okay.
So you don't have to set the rows.
Oh, okay.
Yeah, it's confusing that way. Okay. There's a small soak step here that I do just to ensure that there's a small amount of time that the wash is there, but it's actually the repetitions that are more important. And then there's an aspiration step, just like here, which is identical, that'll remove all of the material, right? And then it'll move the carrier home. That's an important step. And then your loop ends, right? And so it does this 5 times, and at the end of it, you end up with aspirated material that's been washed 5 times. Okay, so this is all fine, and we'll go ahead and save this, right?
So you do one washer at a time, one washing solution.
One washing solution at a time, because you can only add one type of washing solution per micro well plate. Yep. And so so here's just a couple of other small things about exactly how the machine works. So if you have something more complicated and you wanted to, for example, adding it via this tubing is sort of a little cumbersome, and you'd rather use a much larger container, you can set all of these washes to be able to be in these large carboys, and they're labeled A, B, and C. If you go ahead and put any of the programs, so for example, if you put a dispense step on W, you can go ahead and indicate A, B, C, or D, right? And that's fine. And you can put in the flow rate and the volume and more advanced options about where exactly it should do and whether or not there's a delay, etc. So that's definitely something that you can do if it were something that were slightly more high throughput. And right, there's also shaking, if that's important for the assay. You'll notice that we have the biostack turned off. The biostack is this machine right here. If you need to use it, obviously you have to make new programs when you use the biostack. This is made so that it's it's not using the biostat because it just makes it more complicated. We don't need.
Because it's a multiple plates.
Yeah, multiple plates. It uses this little arm to be able to move from here to here. But if we're only using one plate, it's just a little bit of overkill, right? Okay. And so once you've modified something, you can go ahead and put validate. Validation successful. If it says like if you've done something where the program knows that you're gonna screw up, it won't validate. So okay. So now we're ready. Okay. So you can turn it off. Going.
Yeah.
Okay, so now we're gonna go ahead and run our assay. As we just tested it on a blank 96 well plate because that's always a good idea to make sure that you're actually doing what you hope you did. So we're gonna go ahead and run, and it should do what we want. Yep, so it aspirates out the material. That's the wash buffer. This is particularly useful for enzymatic or antibody-based assays where the washing steps really make it difficult to do things with high consistency. That's, I think, the biggest use of making this particularly clean. Ready? Okay, so now we're all done with our washes, and I'm going to show how to prepare this thing for next time to have it all cleaned up. So, all right, the first thing, so we've got our buffer, and again, we're going to go to quick, and we're going to go to purge to remove all of the excess buffer from the tubing. This is fine. Then we're going to go ahead and do an extended wash in water through a prime. You can set up something to do this like more systematically, but I usually just sit here and press the prime button for 30 seconds or so. Make sure that it's been cleaned through pretty effectively. If we're just using buffer with salts, but if you're doing something that potentially might stick to the polypropylene, it's probably a good idea to also use a detergent to clean these out, but that's not going to be super necessary for our particular experiment. Okay, and we're going to go ahead and purge the water. Get it as little as possible. And then we're going to do a final priming step with 70% ethanol.
Oh, okay.
And that's going to dry the tubing.
Okay.
So and that's just important, again, to just make sure that the tubing stays dry, because the wet tubing can get fungus, etc. Okay, so go ahead and purge. There we go. Okay, and so that's enough for just this, but the final step also involves a cleaning to be able to clean off the tips, because the tips have residue from the wash material.
Yeah.
Okay, so to be able to, the first thing we're going to do is take this off, and you can just lay it over the rack here to be able to dry, and all of these little droplets will eventually dry by air. So you want to release the tension before you take everything off, like this, right? And then it should just come off. This comes off like this, and then voila, you're ready to go. And this can sort of just hang out wherever and dry off. And now, so in theory, right, there actually is a cleaning step with turgeszyme, which is super important for for steps again when you're going to use something like BSA. This is a good detergent to be able to clean the whole system. This is something that I haven't done.
Where do I get it?
So I wouldn't worry about it because I don't think that for your particular experiments you're going to need it. But in general, like it's something that over time you can just like Google Turgizyme and get it. Yeah, and you can add it to. This is hooked up to buffer C, and you can create a wash step to be able to wash everything in Turgizyme, and that's not a bad idea. And then follow it up with a wash step. But I'm going to show you what to do without Turgizyme because again, the stuff that we're adding is pretty. Isn't very sticky, it's mostly just salts. Okay, so let's go to open. Okay. So we have a clean, right. So what I have set up here is, so it primes the tips here for with 105 mils of buffer D, which buffer D is hooked up here, and it's water, so we're just cleaning with water. Again, if you use something like Turgizyme or another small detergent, it will clean the tips a little bit better, but for our purposes, not that important. So what we'll do is we'll prime the pump with 105 mils of water, right, submerge the tips, and then we'll do an auto clean step where it sonicates the tips to be able to remove as much gunk as possible. We have this for 15 minutes. The standard protocol calls for an hour. I haven't seen that to be like particularly important, but then I've added a loop step here where it dispenses 300 microliters of buffer D without pre-dispense and then aspirates it, and that's just sort of like an extra final wash step in an empty 96 wool plate. I think it's probably overkill, it's unnecessary, but it is something that I've added. So, alright, so we're ready, and we'll just go ahead and run it. Okay, so we've done our assay, now we're going to go over real quick on how to use the multi-span spec, and it's very, very straightforward. So, okay, so go ahead and turn it off. Okay, it's done with its... Alright, cool. So, I did some... right, so it should say computer control when you're ready to go. It's done with its diagnostic stuff, so you just go to new, right, and we're gonna go ahead and, yeah, just fill it with unknowns. It's fine. Because we're gonna run the whole plate. You go, so okay, fine. We're gonna go to the protocol. And right, so we're going to go to photometric measurement for precision. It's 450 nanometers. That's correct. Cool. Absorbance. Yep. And we'll, yeah. All right. Cool. So, wait out. Oh, I see. We're making delete whatever. So before we go plate in, can we move this down or something? I don't know. It doesn't matter. Alright, so plate out. So go to home and then put the plate in, right, with A. And then put the plate in using the connector here. Then you go to protocol and you could just have it do one thing, right? Do run the measurement at 450 nanometers, and then there's nothing else more complicated that we need to do for this particular assay, so we're just going to have it start. This is fine. Okay. Okay, and we're done. Oh, and it spits it back out. here's your plate.
Mm-hmm.
You can, so now you can go ahead and, okay, so now we're going to go over real quickly about how to do nonlinear curve fitting for the purposes of interpolating the value from a standard curve that you generated from an ELISA, like for A beta 42, which is the data that we're showing here. So to do this, I use PRISM. So it's a proprietary software, PRISM 7. So to be able to do this, just like going through exactly the steps. So you open up the file, and then we're going to go ahead and go to New Project. And then you're gonna, so you can make a bunch of different tables and graphs using PRISM, but the XY is what we need here. So X is the numbers, and then Y, for our particular experiment, we have 2 replicates, and PRISM will use that, so you want to be able to put that in. So that's how you do it, right? And don't use any of the tutorial data, it just sort of like complicates things. So once you get this, you'll get something where you can put in the X's, and then you can put in the 2 replicate Y's here, right? And so I have some of the data already generated in a previous file, and I'm just going to copy and paste it. But so here are this is our standard curve, and then these are our 2 measured values. And here are some made up duplicate values for maybe these are experimental things that we want to know what the concentration of a particular protein is, or concentration of anything, I guess, using a nonlinear fitting algorithm. And so on the x-axis here on this particular graph, this is the concentration of our protein, and these are the spec values that got popped out. So I'm going to just copy and paste all of these from a previous and go to our new file. Okay, so that's there.
If
right?
I don't have that one, so what do I do?
What do you mean?
I analyze, so I don't have that.
You will have all of this information
okay.
de novo. This is what we collected. So
Okay.
right. So what happens? So now you can kind of see it, right? So it creates a graph, and press OK. Right. And so, you know, this is a very nice linear curve, right? You could definitely analyze this using just the linear function here, fit with a linear regression. That's fine. In general, and PRISM will go ahead and like scold you for using a linear regression model, because basically it's just like a very reductionist model for nonlinear fit. So and on some certain kits, it's often not necessarily the best way. In fact, even in the kit instructions for this particular kit, you'll notice the best curve line is actually a curve rather than an absolute line. So it's always probably better to be able to use nonlinear fit. So we're going to use a second order polynomial fit, and this is the one that I usually use for when we're not transforming any of the data. You can use any of these fit models, it doesn't really matter. You can go ahead and...
So where did you get that?
It's going to be under fit or under constraints, but second order polynomial quadratic is what I can use. You can also use linear, obviously. Like in general, linear will serve you correctly and you'll get very similar values, but to do it, you know, the best and most broadly applicable, this is probably the way to do it. So I always use just the standard fit least squared. The other ones are fine. If your standard curve looks kind of funky and you think that there's a lot of noise to it, there is an option for it to automatically remove outliers. And we want to be able to interpolate unknowns from the standard curve, right? And the confidence interval I like is 95%, right? That's sort of the cutoff for p-values, so that's one I use, but you can put it as anything. It'll also just spit you out one number if you want, but I think it's worthwhile to know the confidence interval. So okay, so once you've done all this, right, you press OK, and yeah, so it makes this line, right? It makes the best curve fit, and you can see that it's basically linear and that it did a really good job. So if we go ahead and go to the results, we can look at the R-squared value, and it's quite good, right? And it used 16 values to calculate this fit. Now, I don't understand why it didn't pop out. Normally, it should pop out the, should give us the, I don't know why it didn't. It should give us the predicted values from the interpolation. Oh, there it is. Oh, I see. Okay, so here we go. So, and now we've done it twice. So we gave it these 2 values, right, 1.15 and 0.90, and now it spits out the predicted X, right, from the equation that it made from the best fit, and then it gives you the upper and lower limit. That's the 95% confidence interval, right? So, you know, the approximate value for these particular experimental values is 70 with an upper limit of 72, lower limit of 68, right? Based on the confidence interval that it can measure from the standard curve that you've generated. So using this, you can, you know, if you, for example, these kind of things, I wouldn't necessarily, personally, I wouldn't use these confidence intervals as error bars. I would use the error bars between, because these error bars are incorporate the error in your standard curve and the error in your sample variation that's technical. So meaning the two values that you calculate from the from your analysis, but biologically your error bar should probably be between different biological samples, and you should just take this single number. But I find these numbers to be sort of something that you know, give you a frame of reference as to whether or not, you know, the technical variation in your experiment is very high, and maybe you should consider redoing it. Okay, so so from these values, right, this is what you get. You can just, this is a calculated amount of, for example, A beta 42 into your in your media from using this. So, okay, so that's it.
That's it.